Welcome everyone, welcome to this tutorial on solving the LeetCode problem summary ranges. In this video, we will tackle an interesting problem that involves efficiently finding and summarizing consecutive ranges within a sorted array. This problem asks us to take a sorted array of unique integers and return the smallest sorted list of ranges that cover all the numbers in the array exactly. Each range is represented as A arrow B if A is not equal to B, and as A if A is equal to B. In this tutorial, we will walk through the intuition behind the solution and dive into a Python implementation of the most optimized solution. Without further ado, let's get started. Well, the problem requires us to find and summarize consecutive ranges in a sorted array. To do this, we need to identify the start and end points of each range. Let's break down the intuition step by step. Well, to begin with, we need to check if the nums array is empty. We do this using an if statement. If not nums, if the array is empty, we immediately return an empty list. Then we initialize an empty list called ranges to store our summary ranges. This list will eventually hold the smallest sorted list of ranges that cover all the numbers in the input array. Well, we also initialize two variables, start and end, and set them both to the first element of the input array. These variables will keep track of the current range as we iterate through the array. Now, we iterate through the remaining elements of the array, starting from the second element. By examining each element, we can determine if it is consecutive to the previous element. If the current number is consecutive to the previous number, it means we are still within the same range. In this case, we update the end variable to the current number, efficiently extending the current range. On the other hand, if the current number is not consecutive to the previous number, it indicates the end of the current range. We need to add this range to our range list. To determine the format of the range, we use an if statement to check if the start and end are equal. If they are equal, it means we have a range with just one number. In this case, we add that single number to the ranges list. If the start and end are different, it means we have a range with multiple numbers. In this case, we add the range to the ranges list in the format start, arrow, end. After adding the range to the ranges list, we update the start and end variables to the current number. This prepares us for the next range, if any. Once we finish iterating through all the elements, we need to handle the last range. We use another if statement to check if the start and end are equal or different, and append the corresponding range to the ranges list. Finally, we return the ranges list, which now contains all the summary ranges. By following this intuition, we efficiently identify and summarize consecutive ranges in the sorted array. The algorithm keeps track of the start and end points, constructs the output in the desired format, and optimizes both time and space complexity. The time complexity of the solution is O of n, where n is the length of the input array. Why is it big O of n? Well, we iterate through the entire array once, visiting each element exactly once. This is because we have a single loop that goes through the elements of the array, starting from the second element. Therefore, the runtime of the algorithm scales linearly with the size of the input. Now, let's move on to the space complexity of the solution. The space complexity of the solution is big O of 1. Why is it big O of 1? Although we use an additional list called ranges to store the summary ranges, the space it occupies does not depend on the size of the input array. It remains constant regardless of the array length. Additionally, we use a few variables such as start and end, which also occupy constant space. By having a constant space complexity, we can efficiently solve the problem without incurring significant memory overhead, even for large input arrays. So to recap, To recap, the time complexity of the solution is big O of n, indicating linear runtime, and the space complexity is big O of 1, indicating constant space usage. Understanding the time and space complexities of an algorithm allows us to evaluate its efficiency, predict its performance with larger inputs, and compare it to other algorithms for the same problem. And there you have it. We have successfully tackled the summary ranges problem from LeetCode. Congratulations! I hope you found this tutorial helpful and gained a solid understanding of the problem and its solution. If you have any questions, please let me know in the comments below. And if you enjoyed this tutorial, be sure to give it a thumbs up and subscribe to the channel for more coding tutorials, tips, and tricks. Happy coding and thanks for watching. Goodbye!